Hi everyone, welcome to the SIG Autoscaling meeting on Monday, October 21st. We have a few topics on the agenda, so let's start with those. The first one is around max allowed recommendation cap. Yeah, Omer, I think this is from you.
Yeah.
Do you want to explain or talk about this proposal?
Yeah, we discussed about it in the last meeting. Discussed about it in the last meeting. Just want to make sure we are all think about this and the new steps to continue.
Mhm.
We've had a Slack thread and I've opened the CAP PR as requested.
Okay, and I see there are some comments, but I haven't seen any comments from VPA owners yet. If I can see correctly, I'm happy to give it a review, but I also think we need them to take a look. So we probably need to ping them on the. Actually, I can see Marco, you're here. I don't know if you have any thoughts.
Yeah, sorry for doing that. So we're talking about the cap for max allowed recommendations?
Yes.
Okay. Yeah, so I didn't yet have the time to look at this in detail. Sorry about that. I have some time reserved on Friday to hopefully get to this. I also pinged some people internally who are dealing with this a bit and might have some additional comments. So yeah, hopefully by the end of the week I'll have some better comments from this.
Yeah, so I will also try to take a look this week. Though I think my opinion is kind of less important here, really.
Sure,
Besides that, do we want to discuss any details here, or do we just want to do this offline with a round of review and maybe come back to the meeting if there is some part that we want to discuss later on?
I guess often we will be the best choice here. Maybe Adrian has something to say, but not for me.
Maybe this isn't a discussion for now, but how deep or technical should the CAP process go for something like the VPA? This describes roughly the plan without the specifics, which to me is good enough, but I can also see a need for more details if that's required.
Yeah, so I guess specifically around the part where we are mentioning using the provisioning request API for CA, this needs more details, right? So if we haven't even specifically tried that and saw how this could work, this seems to be a very hand-wavy part then. Right? So you can't really, if we want to have this piece in the CAP, then I guess this needs to be much more detailed than it is right now. For the other things, I think adding a flag is somewhat clear of how that's going to end up. But introducing the dependency on CA is much different. And right now, I think this is 3 sentences or something, right? So.
I think that's I think that's a good call because the provisioning request in Cluster Autoscaler has some very specific semantics in terms of reserving capacity and sort of how it provisions the capacity. It's slightly different than creating a normal pod, so it would be good to sort of consider how well that fits.
Yep, and I also see that Ismail's in the call, so I'm not sure Ismail, if you already had the chance to take a look at the enhancement proposal for max allowed recommendations, and if you already have specific comments, or if you want to do
Yeah,
this in written form.
not. Can you hear me?
Yep.
Okay, yeah, not yet. So
Okay.
we are also interested in this feature, and we already have issue about the very first step, making the most simple step, making these things configurable via Fox. So yeah, I hopefully this week I'll have time to take a deeper look, but so far I feel that we should rather make the first complete the simple thing, make these things configurable from outside via Fox, and then invest in more sophisticated approach, dynamic approaches like VPA discovering on its own the free capacity, like talking to a coaster Autoscaler API and so on. But yeah, I'll definitely take a look and write in the issue. I will indicate.
Mhm.
Okay, so I think we can move to the next topic on the agenda, which is a discussion, I think, of the vertical scaling of nodes. Is the person who proposed this on the call?
Yeah, it's me.
Hi.
My name is Jin Has. Yeah, nice to meet you. Yeah, I'd like to realize vertical device autoscaling. So I would like to explain the detail here. So can I share my screen?
Sure.
Okay. Can you see my screen?
Yes, we can.
Okay, I explain maybe 10 minutes or 15 minutes. But anyway, yeah, I started to explain. This slide shows the background. Why I need vertical autoscaling. So this is background. Currently, generative AI requires enormous computing resources, such as many GPUs. On the other hand, for realizing sustainable world, we need to reduce power consumption. So these requirements are conflicting. So it is expected to balance high performance and power saving. To achieve this, it's important to use expensive GPUs as efficiently as possible. So this slide shows method for efficiently using GPU. There are mainly three methods. First one is make better use of GPUs already in servers, such as time sharing, MPS vGPU, MIG. And the second one is adjust the number of nodes which have GPUs. Yeah, this is the feature cluster autoscaler. The third one is my main topic, adjust the number of GPUs in each node. This is a vertical scaling of GPUs. And there is an infrastructure architecture called composable disaggregated infrastructure, which is called CDI, that can dynamically change the hardware configuration within the server, such as GPS, memory, SSDs, and etc. So yeah, I focus on two and third topics, but I mainly focus on third topic. So at first, I explained the composable disaggregated infrastructure architecture. The left diagram shows the conventional servers, CPU, memory, GPUs, and network cards installed in the server. But in composable disaggregated infrastructure, these components are disaggregated into resource pool. And these resources are connected to PCIe or CXL switch. And then user can compose compose server with any resources. So user can create custom-made server by software definition, so that we can adjust the number of GPUs in each composed bare metal. And next slide shows the architecture. Here is a resource pool, and each components are connected to PCI or CXL switch. And here is CDM manager. CDM manager controls switch fabric to dynamically configure composite bare metals based on user demand. So user can use CDI API to configure composite bare metal configuration. So this is software architecture of CDI. And this slide shows why vertical scaling is required. I think finite resource tuning required to balance high performance and power saving. Here is the example diagram. When users only want GPU, in this case, this is unscheduled pod due to lack of GPUs. This pod requires 2 GPUs, but in this cluster, only 1 GPU is free. So in this case, ideally, 1 GPU is added to node 1. However, if we use cluster autoscaler adds node itself. So in this case, CPU and memory on the added node are not likely to be used, and higher power consumption compared to adding GPU only, and equipment costs increase by nodes. And adding a node takes minutes to tens of minutes, which is time consuming. So for these reasons, I would like to realize vertical scaling of devices. This is what I want to achieve. I would like to achieve both horizontal scale per node and vertical scale per device. This can achieve both power and performance requirements. This diagram shows combination of horizon autoscaling and vertical autoscaling. And this green box means existing cluster autoscaler feature. User can scale node horizontally. And this yellow box shows new feature, vertical scaling of GPUs. So if we can combine horizontal and vertical scale to provide on-demand optimal resources for the type and number of resources required by user workload, we can achieve both power and performance requirements. And to achieve this, composable disaggregated infrastructure is required as the infrastructure. And I'd like to make CD available from Kubernetes. So this is what I want to achieve. And next slide shows architecture of dynamic device scaling by using CDI. Automatically attach or detach GPUs from Kubernetes nodes based on load. And currently, our team are developing 2 features. The first is dynamic device scaling. I call it DDS. This function determines GPU or node increments or decrements based on load. And the second feature is SIG operator. This feature access SIG manager and perform the GPU increase or decrease when the DDS decides to increase or decrease the GPU. So DDS's role is determine whether to increase or decrease devices or nodes. And SIG operator's role is request to increase or decrease devices to SIG manager. And I explained the processing flow of dynamic device scaling. The first step is user create pod, but this pod become unschedulable due to lack of GPUs. In this case, cluster autoscaler get unschedulable pods information, and then cluster autoscaler tries to add nodes which have GPUs. In this case, cluster autoscaler increase the number of replicas in machine set or machine deployment. And then DDS feature monitors the number of replicas. And if DDS detects the change number of replicas, and then DDS determine whether to increase or decrease devices or nodes. If DDS judges the only GPU should be added, DDS changes the manifest of SIG operator, and then SIG operator requests to increase or decrease the devices to SIG manager. And if DDS judge the node should be added now, in this case, just node is added. So this is overall architecture. And I would like to realize this architecture. But currently I have a problem. Here is a problem of achieving both horizontal and vertical scale simultaneously. If user scales a device, the specs of the nodes in the node group will be different. So I need to achieve vertical scaling, keeping current CA concept. For example, if I change the server configuration, I add the GPU, and I detach the GPUs, these node specs are different. So if there is unscheduled pod and this pod requests 2 GPUs, in this case, if cluster autoscaler picks node number 2 or number 3, in this case, these nodes have less than 2 GPUs. So cluster autoscaler does not add additional node because these nodes does not have 2 GPUs. So I think this is a problem. So to solve this problem, currently my idea is we provide node group that can also scale vertically. So in this diagram, node group 1 is a conventional node group. Only for horizontal scaling, the specs of each node must be the same. And regarding node group number 2, this is for horizontal and vertical scaling, and each node specs can be different. So, I would like to realize these node groups. And so this is the basic concept of node group or vertical scaling. There are two consideration points. The first one is how to show node spec in a node group. Regarding conventional node group, cluster autoscaler pick a random node and check its specs to deploy an unscheduled pod. And regarding node group for dynamic device scaling, in this case, I'd like to show always shows fixed specs to CA. So nodes in a node group can have different specs. And the second consideration point is the value of node spec. Regarding conventional node group, CA uses actual node specs. This means actual attached GPUs. And regarding node group for DDS, I'd like to show maximum number of GPUs that can be attached to a node. So not the current number of GPUs. The reason is that even if pod requests more GPUs, Cluster Autoscaler will consider the pod deployable by adding more nodes. So for this reason, I consider these specification. So to achieve this, currently I'm considering to include a fixed spec value in machine set resource so that she always gets the same spec. This means maximum number of GPUs by referencing a spec from machine set. So if Cluster Autoscaler obtains fixed node spec from machine set, I think this problem should be solved. And to achieve this, I'd like to add a new option to machine set. Current Cluster Autoscaler refer to machine sets only if there are no nodes in the node group. So I would like to add a new option called spec fixed and make it always refer to machine set when this option is enabled. So yeah, currently our team is proposing this feature for the SIG Autoscaling community. So the upper diagram shows current Cluster Autoscaler. If when node exists in a node group, Cluster Autoscaler obtains the node spec from the node resources. And when node does not exist in node group, Cluster Autoscaler obtains the node specs from machine set resource. And the below diagram shows our proposal. In this case, when node exists in a node group, Cluster Autoscaler obtains the node spec from machine set. So this is my proposal. And sorry, I would like to explain the more 2 or 3 pages. So please listen. Next slide, I explain dynamic level scaling. Dynamic spin function null scope is red color block. DDS keeps the existing CA concept, so the red box below, including CA, is relevant to DDS. DDS hooks CA processing, such as node increment or decrement, to determine if only GPU increment or decrement is required. So to achieve this, I would like to consider the following mechanism. When she makes node add or remove decision, DDS intervenes to determine whether to add or remove GPUs or nodes. For example, when she instructs to add node, DDS determines whether adding only GPU is sufficient or should add node. And then if she wants to add a node but cannot, for example, the number of nodes reached maximum number of node groups. In this case, DDS consider if it can add only GPU. And then if she decides that the node is not needed, DDS decides whether it is better to delete only GPU or the node should be deleted. And then if she wants to delete a node but cannot, for example, the number of nodes reached minimum number of nodes in the node group. In this case, DDS determines whether it can delete only the GPU. So here is existing CA feature processing flow regarding add resources. If they are unscheduled pods, Cluster Autoscaler tries to add a node. And then DDS monitor the number of replicas. And if number of replicas is changed, DDS determine whether adding only GPU or node. And the DDS does add node instruction or attach GPU instruction. So, and then regarding removable case, if less than half CPU and memory or GPU usage, Class Autoscaler tries to delete nodes. In this case, DDS monitor output unneeded node information in CA pods log. So if DDS detects the unneeded node information, DDS judges it. We only delete GPU or we should node itself. So currently I'm considering this hooks. And then there is other many slides, but it's long. So today that's it from me. So I'd like to hear the opinion of SIG Autoscaling.
Okay, so I have a few comments. I mean, sort of on organizational side, before we go into technical details, we'll sort of add time for the meeting. I can stay for a few minutes longer, but it seems like maybe it would be worth scheduling a separate meeting to discuss this, or discussing it on the next meeting. If you wouldn't mind, maybe sharing the slides with us so we can read it offline and come prepared for discussion. I don't know if that would.
Yeah, I would like to share this document by Google Slide. And I would like to attend the next regular meeting. But anyway, at first, I would like to share this document.
I have a few comments, but I see, Jack, you have a hand, so maybe you want to go.
You can go first, Wojciech.
Okay, sure. I think in general, right, one thing that's worth noting is this seems to be very based on the cluster API provider specifically.
Yeah.
And so we probably want to discuss it not just with SIG autoscaling, but specifically with the cluster API community and cluster autoscaler maintainers from SIG Autoscaler. Sort of like SIG the way in cluster autoscaler we organize work is essentially each cloud provider integration, such as cluster API, has a lot of authority to decide how to implement their integration. So we kind of have separate groups maintaining core logic of cluster autoscaler, and then each provider. I think a lot of this proposal seems very specific to cluster API provider. I think most of this, like changing which node is used as a template, could be done without any change, I think, to core cluster autoscaler logic, just by using existing cloud provider interface and existing processor extension points, which really, I think cluster API provider maintainers would be able to do without like requiring any changes from other providers. I think some on the technical side, some things. So I think basically the requirement for cluster autoscaler node group today isn't really that all nodes in the node group are the same. The real expectation of cluster autoscaler is that all new nodes look the same. So as long as we can predict how new nodes will look like, and they will be identical, the newly created ones. The fact that we have existing nodes that have different sizes shouldn't really break anything, as long as you have the logic that you propose to pick template node correctly. Where I'm worried you may run into problems is unless adding GPU is instantaneous. It's not very obvious for me how cluster autoscaler would understand how many GPUs are currently booting up. So in one autoscaling cycle, you trigger your resize, But then the next cycle, Autoscaler would look for how many nodes are booting up and try to figure out how many GPUs will be there. And yeah, it can cost too much or too little scale up. So I understand you're basically saying you use node as a node template, the node with maximum number of GPUs, which would work, I think. In some cases, you may get slower scale up, as in Autoscaler thinks more nodes, more GPUs are coming up. But yeah, I think it's those implementation details which we may want to discuss in more detail in a next meeting or in a separate meeting. I'm going to give Jack a chance to speak now.
Do you want to respond to Maciek before it? All right, great. I wonder if you have considered from a cluster autoscaler perspective a very, very simple modification, which is to just mark a node for being full or not. And so what we could do in cluster autoscaler is simply bypass all scale out if there's any one node in the node group that's not full. So this would be a way to make cluster autoscaler somewhat cooperative with a vertical scaling actor like this. So for example, if I have 10 nodes and the recipe for building out a new node is to build it out with like 2 GPUs, but I know that can grow to all the way up to say 24 GPUs. So I have another actor in the cluster that's responsible for increasing the vertical GPU capability of each node. And once cluster autoscaler, builds a new node, it's marked by default as not full, which means the cluster autoscaler can't build another new node until that one is marked as full by the secondary actor. So this would be a really simple way to modify cluster autoscaler. So it could just like skip every single time through its loop. It would notice, oh, there's a node that's not full. I'm just going to do a no up and skip any cluster autoscaler because I know that I have a cooperative actor that's on my cluster that's responsible for the vertical part. All the thing, totally, your problem is fairly clearly expressed, but very, very difficult to imagine how you could integrate all this additional stuff into cluster autoscaler cleanly. Because it really is like different than the architectural assumptions of cluster autoscaler. So I wonder if something simple like that has occurred to you. Does that make sense, what I proposed?
Thank you for the comment, but I can't understand all of your comments, so I'd like to check the this meeting recording later.
Sorry, I didn't understand.
Sorry, thank you for your comment, but I can't understand all of your comments now, so I would like to check recording of this meeting later.
Okay, that's fine.
Sorry.
Maciek, did you understand my comment?
Yeah, I did.
By the way, do you upload this recording on YouTube?
I think it should be uploaded. I'll make sure it is.
Okay, thank you.
Okay, so I think because I have still many comments, but I'm also very aware we're 8 minutes past the meeting time. So
yeah,
I think maybe we can continue this discussion on the next meeting. And unfortunately, I don't think we have time for any other topics.
okay.
Okay.
I would like to share the link of document in the SIG Autoscaling Slack later.
Yeah, if you also wouldn't mind adding it to the meeting agenda. I think maybe some people look more at the Slack, some look more at the meeting agenda.
Okay.
I think having it in both places would reach maximum amount of people. Thank you.
Okay. Yeah, thank you.
All right, in that case, thanks everyone, and have a great week. And I think we'll continue discussing this proposal on the next meeting. But also, please add any other topics that you want to discuss to the agenda. Thank you.
Thank you. Bye.